Welcome back. Now, we know how to find the distance between 2 points, and we saw 2 ways to do that. One way was to find the vector from one point to another point, and the other way was to simply use the distance node, which is going to perform those calculations under the hood for us automatically. So with the second method, using the distance node, we didn't even need to use a variable. That vector from point 1 to point 2 is now not even used. Now, let's say we have a situation where we have multiple actors and we want to calculate the distance between these actors. For instance, we may have 3 debug actors. Right now, we just have 2, DA-log1 and DA-log2, but let's say we'd like to have 3 of them in the world. Now, I can take DA-log2 and hold Alt and move it to duplicate that actor. And our outliner recognized that DA-log2 had a number at the end of its name, so it automatically renamed the third one DA-log3. How handy. Now let's say that we want the distance from DA-log1 to DA-log2, and we also want the distance from DA-log1 to DA-log3, and we want to see which one of these is closest to DA-log1. Let's just take our first debug actor, and in the details panel, let's change its box color to red. That way it's different than the other 2, right? And we want the distance from the red box to each of these blue boxes, and we want to see which one's closer. This is a common scenario. You might have perhaps a game where you're running around in a world and you have a pet, and the pet is supposed to attack whichever enemy is closest. That's one example of this kind of problem. So how do we attack the closest one? How do we know which one is closest? Well, this will involve a couple of new concepts. So let's go about learning those concepts. First of all, we need the distance from log1 to log2 and log3. Let's get those distances. We'll go back to our level blueprint. We don't need the from 1 to 2 vector anymore. I'm going to go ahead and delete it. And let's promote the distance from location 1 to 2 in a variable. We know how to do that. Let's go ahead and delete the print string and the float to string conversion node, and let's take the distance from location 1 to location 2. Let's promote that to a variable. Notice it's automatically set to float because that's the data type, and we're going to call this dist underscore 1 to 2. The distance from 1 to 2. Let's hook that up to begin play. And I'd also like the distance from location 1 to location 3. So I'm going to need to get that loc3 actor. It's selected in my level. I'm going to right-click here and create a reference to it. And we're going to calculate the distance from 1 to 3. So I'm going to keep things compact here. I'm going to take DA-log1's actor location. I'm going to drag off of that right here and type distance so I can get a distance vector node. And I'm going to take DA-log3 and bring it down here and use get actor location and hook that in. And now we've calculated the distance from location 1 to location 3. And I'm going to promote this to a variable by dragging out, selecting promote to variable, and I'm going to call this dist underscore 1 to 3. And we now have both of these distances here. And you can organize these to your heart's content. If you want to stack them up nicely and make sure that they're all nice and neat like this, I tend to do that. But there's really no end to blueprint organization. At some point, you have to move on and say that this is organized enough. Now that we have distance from 1 to 2 and distance from 1 to 3, we want to see which one is smaller, right? We want to see which of these distances is smaller so that we can know which of these actors is the closest. Well, in order to compare these two values to each other, we need to use a comparison operator. I want to see if distance from 1 to 2 is less than distance from 1 to 3. So to see if one value is less than another, we can right-click to get our search bar, and we can use this left arrow. On my keyboard, it's the comma key, but I have to hold shift to get it. And we see that we have operators. We have less and less equal. If we choose less, we have this operator. Now, notice the inputs are gray, and if we hover over them, the type says wildcard. That's because this operator is capable of taking in different types. And if we go ahead and hook in a value, such as the value dist1 to 2, let's see what happens. Look at that. The wildcard changes to float. So this node is adaptive to whatever types we pass into it. And we can hook in dist1 to 2 and see if it's less than dist1 to 3. Now, this is getting a little bit out of hand, but these are variables that we have. We don't have to drag off of the set nodes. No, I'm going to go ahead and break those. I'm going to use our variables. I'm going to drag them straight onto these pins. And that way, we don't have to cross our wires so much. So what does this node do exactly? Well, it performs a comparison and then returns a value. It checks to see if the first value passed in is less than the second value we pass in. And it returns this value. If we hover over that, we see that it's a Boolean value. So what is this Boolean value type? Well, it's a type that can be one of two values, true or false. So this is different than the float and the vector types. Float can take on a wide range of values. It can be equal to 0. It could be equal to 1.579. It can be 3.14159. Floats have a wide range of possible values that they can be, whereas Boolean has a very limited range of values. There are only two possible choices, true or false, and this allows us to make decisions based on whether the Boolean is true or false. How do we make those decisions? We have to branch. There is a specific kind of node specifically made for this. It's called the branch node. Notice it's under flow control, and look at the icon. It's a line splitting into two arrows. Now, if we go ahead and select that branch node, notice it has one input execution pin and two outputs, one labeled true and one labeled false. And it also has an input that takes in a Boolean. Now, yes, we can hard code a value, and a Boolean value in Unreal Engine can be set with a checkbox. A checkbox has only two states, unchecked and checked. As far as Unreal Engine is concerned, unchecked means false and checked means true. But we don't want to hard code that value. We want to pass in the result of our comparison. We just compared two distances. Now, if the first one is less than the second one, this value will be true. If the first one is not less than the second one, then this value will be false. And then we can hook up logic to true and false. So we have this branch in our logic. Let's see how it works by hooking it up to our flow of execution here. We want to do something if the distance from 1 to 2 is less than the distance from 1 to 3. That would mean that the debug actor DA_locK2 is closer to 1 than 3 is. So what do we want to do in that case? Well, if 2 is closer, I'd like to draw a debug sphere at 2's location, right? DA_locK2, I'm going to select it from over here and come back over here and Control D to duplicate it. I'm going to get actor location and I'm going to draw a debug sphere. So let's get a draw debug sphere node and we're going to hook in that actor location here. And we're also going to take this true branch and hook it up to draw debug sphere. And I can set the radius, let's set it to 25. I'm going to set the segments to 24 just to be fancy. And I'm going to set the color to something like a pink and set the duration because this is not in tick. We're going to set its duration to 600. So this is the line of execution that will be executed in the true case. But if the Boolean passed in is evaluated to false, then we're going to do something else. I'd like to draw the debug sphere at location 3 because that would then be the closest one, right? So I'm going to take DA_locK3. I'm going to actually copy the get actor location node as well and Control D. And I'm going to take my draw debug sphere and duplicate that as well, hooking in DA_locK3's location. And I'm going to hook this draw debug sphere up to the false case. Now I'm going to take these three nodes, select them and hit Q so they're nice and straight. And I'm going to do the same thing for these three up here. So let's recap on what we're doing before we play test this. We're calculating two distances. The first distance is from 1 to 2. The second distance is from 1 to 3. We want to see which one of those is smaller, which one is less. So we used our comparison operator, the less than operator. If the distance from 1 to 2 is less than the distance from 1 to 3, the comparison operator will return a Boolean value of true. But if that condition is not met, either because these two values are exactly equal or the distance from 1 to 3 is less, well, then we'll get a false. So we know that in the true case, dA log 2 is closer to dA log 1. And in the false case, dA log 3 is closer. We can test this out. Now, let's just make sure that we know which of these is which. In my level, here's my dA log 1. It's going to be drawn with pink. And this one, which is closer, clearly, that's dA log 3. That's where I expect to see my debug sphere. And the one that's out here that's farther away, that's dA log 2. I don't expect to see the sphere on that one. Let's press play. And sure enough, my debug sphere is on the closer one. So it's as expected. Now here's the nice thing about conditional logic. That's right, conditional logic is when we have logic that depends on a certain condition. Here the condition is this Boolean value, the result of a comparison. That's our condition. You see, one of these lines of execution was executed and the other never was. We have two branches, and which one gets executed? Well, that depends on the condition. What's the Boolean value, right? And this is adaptive to the situation. What if we change the situation by taking dA log 3, which was previously the closest one, right? What if we move that way out here, farther away? Now it's not the closest one anymore. Well, if we press play, well, check it out. We're now drawing the debug sphere at the other actor's location. So we're executing a different branch in this case in our blueprint logic. So branches are very, very useful. We can execute one set of instructions under one condition and another set of instructions under another condition. And we have a number of different types of operators. We can check if one value is less than another. That's what we're doing here. We can check if one value is greater than another. We can also check to see if one value is less than or equal to another, or if one value is exactly equal to another. We have lots of options, and we'll get plenty of practice using those options all throughout this course as we start doing some more exciting things. So in this video, we learned a couple of new things. We learned about the comparison operator, specifically the less than operator. We learned about what Boolean values are and that comparison operators return Boolean values. And we learned how to use those Boolean values with a branch node to split our lines of execution so that our blueprint scripts will execute one line of execution in one case and another line of execution in another case. This is a very important concept in scripting and in programming in general. This comes from programming, as most of these concepts have. So excellent job. This is definitely one of those concepts you would take notes for, but of course, we'll be getting plenty of practice all throughout the course. Excellent job, and I'll see you soon.